In this video, we're going to take a look at few examples on indices. Yeah, in my previous video, I gave the laws of indices and I proved them. Most of them. I proved them. So if you aren't familiar with the laws of indices, it would be best that you pause this video and you go to see that video I made earlier, or you just have an idea of it, perhaps by checking your textbook or something. So let's get started. The first example I have here is simplify 16 raised to the power of -1/4. So let's see. 16 raised to the power of -1/4. Now this 16 here means 2 to the power of 4. So then I can bring this. I haven't done anything much. 16 means 2 to the power of 4. Then I brought the -1/4 here. So there was a particular law I gave. That should be law 3. I gave a law in the previous video, and as I said, because we're making use of the law, so it's best you are familiar with the laws. So law 3 is any number to the power of this n times means this is raised to the power of mn. So as you can see, if you check well, they kind of look alike. Here is 2 here, you see, then 4 here is m, then n here is -1/4. So I can apply that and put it here. I have 2 to the power of this, then it's equal to this 4 multiplied by this. So 4 cancel the other 4 out, and that's 1. We have 2 to the power of -1. There was another law I gave. That's law 8. Law 8 said any number raised to the power of negative number means this. That means this. So comparing this again, a is like 2 here, then this is like n. So I have something like this, and again I gave a law. I said that was law 7. Law 7, that any number raised to power 1 means that number. So applying that, something like this, like this. So I have 1/2 raised to the power of 1 means 1/2. So the solution to this question is 1/2. So you could have another question that would have negative. It could be anyhow, in any form, so it's still the same approach. So let's see the next example we have here. We have expressed with positive indices. In the previous video, and I already explained, I already said the meaning. I gave the meaning of indices. The word indices is the plural form of the word index, and it means power. Index means power, so definitely indices means powers. So since this question says express with positive indices, definitely by the time we are through solving, that is after we must have gotten our answer, we must make sure the power of the answer we get is positive. That is, the power must be positive. So let's get started with it. So we have x to the power of -2, y to the power of -3 is equal to this. Then I can have something like this. This could come under this. You said, like, I just try and interchanged these variables. Those ones with power should be together and numbers should be together. So I can pair here, then I have something like this. So I could just pair. Then there was a law I gave again from law law 2. I gave a law, I said a to the power of m divided by a to the power of n, that it could be in this form or this form, that a to the power of m, well, it means the same thing. So they both mean a to the power of m minus n. Yeah, so comparing that, the one we have here is of this form, so something like that. So compare, then you have this first one to be x to the power of negative 2, this, and y to the power of this, then z to the power of negative 4, this, then I have 9 over 6, then I have 3, then 2, 3 here, 3, then 3 and 6, I have 2, then I have x to the power of negative 5, y to the power of 6, z to the power of negative 8, then I have 3 over 2. But this could have been an answer, not really like this. I would have just written like 3 over 2 x this, like that. But the question says express with positive indices. So these guys here, we must try and make sure that powers become positive. So there was this law I used in the law in example 1, that is this law 7. I gave this law in law 8 rather, sorry, law 8, that is this, should be this. So definitely x to the power of negative 5, if we compare, this equation becomes something like this, then y to the power of 6, then 1 over z to the power of 8, then 3 over 2, sorry. Then our final answer becomes 3 y to the power of 6, then 2 this. Yeah, so these are final answer. Yeah, let's see the next example. Next example I have here is something like this. So this question, actually I'll be using 2 methods to solve this question. So let's get started. This dot here, I know most of you are familiar with it. It's multiplication. It means multiplication. So let's just go at it. 4 means 2 raised to the power of 2 dot 2 raised to the power of n plus 1 2 raised to the power of this, like that. Then I have something like that. Yeah, from law 1 now. From law 1 is a to the power of m multiplied with a to the power of n is a to the power of m plus n. Now this is the right hand side, the left hand side. Then you find out that this 2 raised to the power of n plus m is like this. So I could bring it to something like this, that 2 raised to the power of n, then 2 raised to the power of 1. I could bring it like that, comparing. So definitely, and I can do that to this also. So let's see. Then that's one that becomes something like this. Yeah, doesn't mean actually. So then 2 to the power of n, 2 to the power of 1, 2 to the power of n. So I found out that 2 to the power of n is common here, and it's also common here. So I factorize it. Then I have something like this left. Yeah, so then 2 to the power of n cancels out. Then we're left with 2 to the power of 2 dot 2 to the power of 1, 2 to the power of 2, then 2 to the power of 1 minus 1. Then this, I could still factorize 2 to the power of 2 out. It's common, so I'll have something like this, 2 to the power of 1 minus 1, then 2 to the power of 1 minus 1. So this could cancel out. Then we have something like 2 to the power of 2, that's 4. Yeah, from here, a lot of questions running through your mind. I could still have something from here. I could still just proceed. This is not the second method actually. Just trying to show you something here. I could have something like this. From here, 2 to the power of 1 is 2, then minus 1. And I have 2 to the power of 1, 2, minus 1, although it doesn't mean. So 2 to the power of 2 is 4, Then 2 minus this is 1, 1. That's 4 over 1, and that's 4. Same thing. So yeah. So let's see the second method now. Let's see the second method. Yeah, let's see the second method. Let's see the second method. Later, alternative method to that. So from that question, let me write it again. 4 dot this n plus 1. Then I have my 2n plus 2, 2 n plus 1. Now I have this. The second method is, I could just say let n equals any integer. Integers are positive and negative whole numbers. So I could say let n be any integer. E.g., for this particular question, I could say let it be 1. Any small integer, actually, any small integer. It could be -1, -2, -2,300,000, any number. So, but it's just best one uses a very small integer. Although negative numbers are still smaller. I could have used negative number here, but I just prefer 1. Most time I use 1. So irrespective of the number you use to get your answer. So let's see. So anyway, I found my n here, I substitute 1 instead. Then I have something like this. Then I have something like this. I prefer to do it anyhow, so I don't have something like this. Yeah. Then this is 4 times 4. I have 16. 4 minus 2. Then I have 8 over 2. Then I have 4. Same answer. So you could just try it as many as possible questions using this method. So let's see. This is the last question we have here. This is an exponential question. That is question that deals with power. So, but will later lead to quadratic equation. So that's it. We're asked to find the value of x here. Yeah. So I have something like this. Just from law 1. From law 1, what I did the other time to the previous question. That means this. I purposely started from here now, since I've already explained in the previous example. So I have something like this. 2x. Then I have 2 to the power of 2. Then 2 to the power of 2x. So I could do that here. 2 to the power of 2. Writing the question now. Then 2 to the power of 2x. Then I have 3. Multiplied by 2 to the power of x minus 1. Then this means I could say, okay, before then I could say something like this. Then x whole squared, then plus 3 times 2 to the power of x minus 1 equals 0. I could say let 2 to the power of x equals y. Any letter actually. Yeah, any letter. Then I proceed, I say 2 to the power of 2 dot y, 2 like this, and 3 dot, y now, y, and I have something like this. Then it becomes 4y squared plus 3y minus 1. So thereafter we moved on, say factorizing. I have something like 4y. I have something like y plus 1, but then my 4y minus 1 should be equal 0. So I have something like 4y squared. So that I say, so either y plus 1 equals 0 or 4y minus 1 equals 0. So I could say, therefore, y is -1 or 1 over 4. But this is not the answer. In most O-level exams and most exams, you find out that this could be in the option, and students that aren't very careful could just be in a haste and just pick this answer. So never forget that we're asked to find the value of x and not y. So we have to do that back. Say, but 2 to the power of x is y. So you say when y is -1, when y is -1, then I have my 2 to the power of x, it should be -1. But this won't have any solution because there's no number I would raise to power to any power. There's no number there's no number I would raise to the power of 2 that would give me -1. So no solution to this. No solution. No solution. So when y equals 1/4, I have 2 to the power of x to be equals to 1/4. Then I have 2 to the power of x equals 2 raised to power -2. Basically, this means 1/4 means 1/2 raised to the power of 2. Then from this law, from that law, I gave you something like a to the power of -n means 1/a, like this. So this guy is already in this form, so I brought it back to this guy like this, something like that. So I say, you say equating powers, therefore x is -2. Yeah, x is -2. So it means this equation, the original equation, this has just one solution, and the solution is -2. Yeah, thanks for watching this video. I would like you to subscribe to my YouTube channel if you haven't subscribed before. Yeah, click on the like button also, then share the video.